Okay, in this video we're going to be talking about sets. Now, a set is basically a group of something. It could be something just a bunch of individual things, like it could be a set of numbers, 1, 3, and 8. Or it could be a group of items like animals. Okay. Now, sometimes within a set you have something called a subset. It means you can break it down further. So, for example, animals, you might break it down into mammals, which you might break down into dogs, which you might break down into, I don't know, poodles. But each one of these is a subset of the previous set. So with numbers, for instance, 1, 3, and 8 is my set. I can have a subset with 1, a subset with 3, a subset with 8, or any combination thereof. Okay, 1 and 3, 1 and 8, 3 and 8, those are all subsets of this original one. Now, the real number system is a set of numbers that can be broken down into smaller subsets. Now, the first division comes between irrational and rational numbers. An irrational number can't be written as a fraction. So these are things like pi. It's a never-ending decimal that never repeats. Or any non-perfect square root, like the square root of 2. Square root of 2 is a non-perfect square root and cannot be written as a fraction. But a rational number can be written as a fraction. So these are things like counting numbers. It could be -5. Well, how do I write a counting number like this as a fraction? Well, you do it by putting it over 1. It could be a actual fraction like 3/8, or a mixed number, so 1 1/5. It could be a decimal that ends, 0.25 for instance, or it could be a decimal that repeats. Those can all be written as fractions. For instance, this is 1/4, this is 2/9. Now, rational numbers can be broken down further. A subset of that is integers. Now, these are counting numbers that include both positive and negative. So it could be -3, -2, -1, 0, 1, 2, 3, and so on. Whole numbers exclude the negatives, so whole numbers start at 0. Natural numbers is a subset of this one, and it drops the 0. It starts at 1. So these are what I call the kindergarten numbers. You start counting in kindergarten with the number 1. So 1, 2, 3, and so on. So let's look at some examples. The square root of 3. This is a non-perfect square root. It is a real number, but you cannot write this one as a fraction. If it can't be written as a fraction, it's irrational. Sometimes before classifying a number, though, you are going to have to simplify. For instance, pi is irrational, but that's not what this expression is. It's pi minus pi, which is 0. And 0 is what we're classifying. Now, 0 is a real number. Can we write it as a fraction? Well, 0 over 1. So that means it's also rational. Is it a counting number? Can it occur on a number line without having to go in between numbers? Yes. So that means it's an integer. Whole numbers start at 0. so it is also a whole number. And we stop here because natural numbers start at 1, not 0. So looking at this one, again, if you can simplify the expression, you need to do so. Square root of 36 is 6, so what we're classifying here is negative 6. Well, negative 6 is a real number. These are all real numbers. We're doing imaginary numbers later in the year. Now, negative 6 can be written as a fraction if you do negative 6 over 1. So it's also rational. Integers are counting numbers like negative 6 and includes the negatives. And this is as far as we go because whole numbers and natural numbers don't include negatives. 0.22. 0.22 is a repeating decimal. It is a real number, like all of these, and can be written as a decimal. As a fraction. It's 2/9. Any repeating decimal can be expressed as a fraction. So, it is also rational. However, it is not a counting number. It doesn't occur on a number line like we would expect. It's kind of in between. So this is where we stop. Square root of 2 over square root of 2. This simplifies to 1. 1 is a real number. It's a rational number because we can express this as a fraction by putting it over 1. It is an integer because it's a counting number. It is a whole number because whole numbers start at 0 and it's greater than that. And it's a natural number because natural numbers start at 1. Okay. So any number can be classified as to belonging into some combination of these sets. Now, real numbers also have certain properties. These might seem familiar to you from other math classes. For instance, the commutative property. The commutative property basically tells us that when adding or multiplying, the order you do it in doesn't matter. So if I do 2 plus 3, it's the same thing as 3 plus 2. I'm going to get 5 either way. Same thing with your multiplying. If I do 5 times 6 or 6 times 5, it doesn't matter which way I do it, which order I do it in, I get 30 either way. So for the commutative, order doesn't matter. For associative, it's your grouping. So 1 plus 2 plus 3 would give me 6. Same thing as if I did 1 plus 2 and then plus 3. The grouping doesn't matter. Same thing with multiplication. If I do 2 times 3 times 4, or 2 times 3 times 4, I get the same way either way. I get 24. So for associative, the numbers that associate are different. So with this one, grouping doesn't matter. Now inverse, think of the word opposite. Now additive inverses and multiplicative inverses look a little bit differently. So for instance, the additive inverse of 2x is negative 2x. So for the additives, an inverse property will have positive and negative of the same number. But when you're multiplying, oops, I had that right the first time. There we go. The sign doesn't change. They're just reciprocals, but they're still opposites of one another. Now, the identity property is when you do something to a number and get the same value of the same number. So, for instance, if I do addition, if I add 0 to a number, I'm not changing the number. Or if I take a number and multiply by 1, I'm still going to get that same number. So identity property is when you do something to a number and get the same number as an answer. Alright, distributive I think is kind of easy to recognize because you are distributing. So 2 times x plus 3, if I distribute it, I would get 2 times x plus 2 times 3. Or you can just write 6, same thing. Okay. If you're just glancing at it and not paying much attention to the numbers, an easy way to identify it is if you have parentheses on one side but not the other. Okay. Now another property is called the closure property. Now the closure property is, okay, basically a set of numbers is closed under a specific operation, like adding, subtracting, multiplying, or dividing, if when you do that operation your answer is still a group or still part of the same set. So let me explain with an example. If I say negative numbers are closed under addition, this means if I'm saying that anytime I have a negative number plus another negative number, I get a negative number as an answer. This is true. So negative properties are closed under addition because the set of negative numbers, anytime you add one member of the set to another member of the set, you get a third member of that set. So if I say whole numbers are closed under division, what I'm saying is if you take a whole number divided by another whole number, I get a whole number as an answer. This one, though, is false. For example, if I do 1 divided by 2, I get 0.5, 1/2. This is not a whole number. It's rational, but it's not a whole number. A third example, if I say odds are closed under subtraction, this means if I take an odd number, minus, I was about to do addition, another odd number, I get an odd number as an answer. This is also false. So for example, if I take 5 minus 3, I get 2, which is an even number. Alright, I think that's it for this particular video. So, I'll see you next time.